Okay, example 4. I know that last year in Algebra 2, for the first time, there was more emphasis on increasing and decreasing. When is a function increasing? When is it decreasing? So remember, what we mean by increasing is that the y values are getting bigger as you go from left to right. Right? Decreasing means the y values are getting smaller from left to right. Right? Constant means it's a flat line, it's a horizontal line, nothing's changing. Okay. This graph here, it's starting here and it goes up. It does a little bit of a slowdown right around the origin, but it just keeps going on up. Would you say that that graph is increasing or decreasing? It's increasing because from left to right, the y values keep getting bigger, right? But remember that when they ask for open intervals of increasing, decreasing like this, the intervals that they're talking about here are of x. So you're always giving the answer in terms of where on the x-axis is it increasing. In this case, it's not really very interesting because we're just going to say all real numbers in any case, right? So this one we would say all reals is increasing. No, it's never decreasing. There is no interval of decreasing on this graph. It's always increasing. From left to right, it's always going up. That's what you're looking for. No, I'm just looking at the graph. It looks like it's just a continuous from the left to the right. It's always increasing. And these, you can just assume that these arrows go on forever. So all real numbers. Look at the next one and see how it's different. Yeah, it never flattened out to give you. We'll see one like that the next slide. Okay, notice on this one, it changes, right? It's increasing as you look from the left side of the graph until it gets to this value, right? Now, in terms of the x-axis, what is the interval over which it's increasing? You could put negative infinity to represent the left side. Where does it stop increasing? At -1, right? You would say increasing is negative infinity to -1. You're just using the x values, right? You're not going to use the 2. What's that? That's not an ordered pair. This is an interval, right? Just like we do, -3 is less than x is less than 5, and just use interval notation. You could say it like this: we would probably say x is less than or equal to, or we would say x is less than -1. That's an interval where it's decreasing. As an interval, you'd say negative infinity on the left, -1 on the right. And it's an open interval because it never includes the endpoint. Right there at -1, that's right in between increasing and decreasing. It's not doing either. So the open part of it means just use round parentheses all the time. And less than, not less than or equal. Okay? Where else is it increasing on that graph? From 1 to infinity, right? From this point over, it's increasing. So you would say 1 to infinity. Okay? Where is it decreasing? Yeah, from here to here, it looks like it's going down from left to right. So again, you just say the x values, -1 to 1. Right, that's it. Yeah, I mean, if you want, you could say -1 is less than x is less than 1. It's the same thing. But this is what you're going to see in the book. So I want you to just not be confused when you look in the book. Sure, either one, doesn't matter. Okay, so now this is the graph of a piecewise function, right? It's different from negative infinity to 0, and then it's different from 0 to 2, and then it's different again from 2 to infinity. What's the interval of increasing? Negative infinity to 0. Okay. What's the interval of decreasing? Right? It's decreasing on that segment right there. So it's starting at x equals 2, and then it goes down all the way to infinity. So 2 to infinity. And then what's it doing between 0 and 2? It's constant. It's not changing. So constant interval would be 0 to 2.